Good morning, everybody. What are the portions covered till today? Very important examination point of view and also for you. So almost all the examinations of engineering in second semester and also in the almost all the competitive examination, you have a question on refrigeration and air conditioning. First, introduction. What is the refrigeration and air conditioning? There is nothing but artificial cooling in order to remove the heat from the system. So that is two types. One is refrigeration, other one is air conditioning. So we use refrigeration and air conditioning for cooling the system. First one, that is refrigeration. So all of you see refrigerator in your house. So for keeping the groceries, food items, milk, medicines, and other items, you can keep it long time without decaying. And another thing is the air conditioning. Nowadays, air conditioning is very much essential for your home, hospitals, and computer centers. There you need the air conditioning. So the artificial cooling is divided into two. That is refrigeration and air conditioning. Refrigeration is nothing but heat transfer from lower temperature zone to the higher temperature zone. That is nothing but reducing the temperature of the compartment or system. Next, come to the point, the principle of refrigeration. That is nothing but a heat transfer from lower temperature to the higher temperature, and this satisfies the second law of thermodynamics. Remember, all of you, this particular refrigeration satisfies the second law of thermodynamics. That is nothing but the external work. From that external work, you can carry out the heat transfer from lower temperature to the higher temperature. So we know that refrigerant. So if you have any problem with the fridge, that is the cooling effect is less, and you contact a mechanic, that is the refrigerator mechanic. He said that the gas present in the refrigerator is less. Due to that, you are not getting the optimum cooling effect. For that, what is the reason is that is the refrigerant which is used in the refrigerator is the main item. From that, you can extract the heat from the compartment and transfer the same to the environment or surrounding. So that is the refrigerant. That refrigerant is nothing but the gas. See, these are the few common refrigerant which is available in market. That is ammonia, freon, freon 12 and freon 22. Remember, freon 12 is used in refrigerator and freon 22 is used in air conditioner. And methyl chloride. So this is the one which is used in usually in cryogenics. See, all of you seen the satellite. So in the satellite launch vehicle, the fuel is hydrogen and nitrogen. So there, for keeping the temperature of the fuel used in cryogenic engine, they use methyl chloride and carbon dioxide. So these two are very much used in the cryogenics. Say, remember, the commonly used refrigerants are ammonia, freon, methyl chloride, and carbon dioxide. Next, come to the point, the refrigeration concept. So that's nothing but the refrigeration concept is nothing but heat flows from higher temperature to the lower temperature, or in turn, you can say a lower temperature to the higher temperature. So both, that is the extracting the heat from the compartment or from the system. That is, when you circulate refrigerant in the evaporator and condenser, there will be increasing and decreasing of the pressure of the freon. Due to that, the temperature increases and decreases. Next, come to the point, the boiling and freezing temperature of the refrigerant. So this depends upon the type of condenser and the compressor you use in the refrigerator. And next, very, very important thing is the refrigeration which satisfies the second law of thermodynamics. This is nothing but from the external work. Say external work means you have a compressor. Inside the compressor, there is a motor. For running of the motor, you provide the electric current. So due to that electric current, providing the electric current to the motor, that's the external work. From that, you heat transfer, you make the transfer of heat from the refrigerant to the surrounding. That is, in the meantime, the temperature decreases, pressure increases. So this concept satisfies the second law of thermodynamics. Next, come to the point. All of you mark it very, very important. The parts of the refrigerator. Many question paper, you have a question on the parts of the refrigerator. So all of you observe here. There will be 4 main parts are there. That's very, very important. Then these are the components which is required for refrigerator. First, come to the point: compressor or pump. You can call it as heart of the refrigerator. Heart of the refrigerator. And then you have the condenser. Here, the condenser means the name itself indicates the contents of the refrigerator. That is, the pressure increases. In the meantime, temperature also decreases. Temperature decreases. And then the refrigerant is fed to the expansion device. Due to the expansion of the refrigerator, temperature decreases, pressure decreases, and then from the expansion device, the freon is fed to the evaporator. There, the evaporation of the freon takes place, the refrigerant takes place. Then, after low pressure, low temperature, refrigerant is fed to the compressor. In compressor, refrigerant is compressed, pressure increase, and then it is fed to the condenser. Here, the temperature decreases, pressure increases, and also pressure increases, and then it is fed to the expansion device. The cycle continues. This cycle is continuous. All of you, please mark the arrow marks here like this. See, the refrigerant from the compression is fed to the condenser. From the condenser, refrigerant is fed to the expansion device. And from the expansion device, again, the refrigerant is fed to the evaporator. From the evaporator, again fed to the compressor. This cycle continues. Due to this continuous cycle, heat extracted from the system. System means the front portion of the refrigerator. You have a freezing compartment or the compartment where you keep the medicines, milk, groceries, food items, and other things. So this cycle is continuous. From this continuous cycle, the heat extracted from the material or the items kept in the freezing compartment. Next, come to the point, is the explanation of the expansion device, condenser, compressor, and next come to the point, coefficient of performance. This is very much essential for mechanical engineers. In 5th semester, you have the mechanical lab, engines lab, where you have to calculate the COP of the refrigerator. That's nothing but it's the ratio of input to the output. See, the heat absorbed or removed, that's the Q, that's in kilowatt, and the work supplied, that is the ratio of coefficient of performance equal to, it is the ratio of input to the output. Input is W and output is Q. That is the work supplied and the heat absorbed. The work supplied is running of the compressor through the motor, and due to that, freon refrigerant is compressed, released, compressed, evaporated, and expanded. Due to that, the heat transfer takes place from low temperature zone to the high temperature zone. Next, come to the point, relative COP. So this is very much essential. So how much coefficient of performance when it is compared to the other ones? That is the relative COP. That is the ratio of theoretical COP to the actual COP. Say in case of relative COP of the refrigerator, always you have 60% or 70%. That is from the COP, if you calculate from the equations, you will get some amount. But the actual COP available, if you calculate from the actual reading, temperature reading, you calculate in the refrigerator, that is less. Due to that, the COP is always less than 1. So less than 1. Actual ratio of theoretical COP to the actual COP. Next, come to the point. Yesterday we discussed about vapor compression refrigerator. Say the refrigerator you have in your house. This is the one. This is the vapor compression refrigerator. Vapor means that's the Freon 12 which is used in the refrigerator. It is made vapor and compressed in the compressor and again condensed in the condenser, again fed to the expansion device and again which is fed to the evaporator, and there the Freon 12 evaporates and pressure is decreased, temperature is decreased, again is fed to the compressor. All of you observe here with the cursor movement. See, all of you observe here the dry refrigerant. This is the evaporation unit. Say from here, from the evaporation unit, less temperature, less pressure, refrigerant coming in this direction. All of you observe the arrow mark and is directly fed to the compressor. In the compression, pressure of the refrigerant and the refrigerant is compressed. Due to that, there will be less temperature in the refrigerant and pressure increased. And then it is fed to the condenser unit. Condenser unit. Here, the refrigerant is condensed, and then here the pressure of the refrigerant is reduced and pressure is also increased. Due to that, the temperature, the heat is absorbed by the refrigerant from the surrounding. Then that is fed to the throttle valve. From the throttle valve, again it is fed to the evaporator. See, all of you observe here, you have the freezing compartment. So all of you, if you open the door, you can see the compartment or chamber where you keep the food items and medicines, other items. So that backside of that, you have the evaporation unit. So this is the cycle completes. From the evaporator, refrigerant is fed to the compressor. In compressor, the refrigerant is compressed and pressure increases. The increased refrigerant pressure and reduced temperature is fed to the condenser. From their condenser, pressure of the refrigerant increases and temperature reduces, and again which is fed to the throttle valve. From the throttle valve, it is fed to the evaporator. So cycle is continuous due to the movement of the refrigerant from evaporator, compressor, condenser, expansion unit, and to the evaporator. Due to this, which extract the heat from the material or the items kept in the freezing compartment. This cycle continuous. This cycle is continuous. Due to that, heat extraction takes place. All of you remember, this is domestic. Remember, in the examination, you have the question domestic refrigerator. Domestic refrigerator means nothing but domestic refrigerator means that is vapor compression refrigerator. Remember, in your lifetime, the domestic refrigerator means vapor compression refrigerator. See, the vapor of the refrigerant, that is Freon 12. Freon 12. The name of the refrigerant used in domestic refrigerator is vapor. That is the vapor of the refrigerant. The refrigerant used in the vapor compression refrigerator is Freon 12. All of you remember this diagram. All of you please write down the question. Explain briefly with neat sketch. Neat sketch. Vapor compression refrigerator. All of you write down the question. Vapor compression refrigerator. Put a question mark. Continue the question. List the applications. List the applications and limitations. List the applications and limitations. Say, for listing of applications, one is domestic purpose, another one is keeping medicines, another one is keep the items for long time, before decaying. Like this, write a minimum 5 applications. And limitations, you have to write the initial cost of the refrigerator is high and maintenance little bit difficult or easy, and you can write any 5 advantages or the advantages of the vapor compression refrigerator, or you can write the uses of the vapor compression refrigerator. Next, come to the point. This is the explanation of the vapor compression refrigerator. Next, come to the point. The another type of refrigerator which we use in laboratories or research purpose. Research purpose. Say here, the vapor absorption, that is compression in the previous case. Here, absorption, that is the vapor of the refrigerant which is absorbed in the system. All of you observe here the vapor absorption refrigerator. So the main difference between the domestic refrigerator and the vapor absorption refrigeration is there the compression of the refrigerant takes place. Here, absorption of the refrigeration takes place. Next, all of you observe here the parts of the vapor absorption refrigeration. Say, all of you observe here, here the dry ammonia vapor. Remember, in vapor compression, we use Freon 12. Here, we use ammonia, remember. So, in vapor absorption refrigerator or refrigeration system, we use ammonia vapor. We use ammonia vapor as the refrigerant. See here, you have a container. It is also called as absorber. And here the vapor is absorbed and sent to the circulation pump. Again, there will be a heater. From that, the ammonia solution and the absorber send the strong ammonia solution to this condenser. Then the warm strong ammonia solution is fed through the heater, and again which is fed to the condenser. Where the condensation of ammonia, strong ammonia solution takes place, and again that is fed to the expansion valve. Their expansion takes place. Again, that is fed to the evaporator. So through the evaporator, again the ammonia is fed to the absorber unit, where the absorber contains the fluid which absorbs the ammonia, and a weak absorbed ammonia solution is fed to the pump. To the pump, it is fed to the condenser through the heater. Here the ammonia solution, weak or pressurized ammonia solution is condensed, and the pressure increases in the condenser, and again which is fed to the expansion valve. Again from the expansion valve, which is fed to the evaporator. Again from the evaporator, ammonia refrigerant is fed to the absorber. This is the cycle in which the ammonia, that is the refrigerant, is passed through the evaporator, from the evaporator absorber unit to the pump, then heater, and again condenser, and from the condenser it is passed to the expansion valve, again which is fed to the evaporator. The cycle is continuous. From this, the heat from the material kept in the freezing compartment, that is removed. So this is the principle of operation of vapor absorption refrigerator. Vapor absorption refrigerator. Say here the ammonia used as the refrigerant, but in the previous case the Freon 12, F-R-E-O-N, Freon 12, that is used as the refrigerant in vapor compression refrigeration. In case of vapor absorption refrigeration, we are using ammonia as the refrigerant. And so here in the absorber unit, which contains the solution, that is the liquid, which absorbs the ammonia and presses the weak ammonia solution to the circulation pump, and then from the circulation pump, which is fed to the circulating pipe, through the circulating pipe, which is fed to the heater, the ammonia solution passes through the heater, increases the temperature and reduces the temperature, increases the pressure and reduces the temperature. So that is the weak solution passing through the circulating pipe. The temperature increases due to the presence of heater. So here the solution passes through the heater again, which is pressed to the condenser or fed to the condenser, where pressure of the ammonia solution increases. In the meantime, temperature of the ammonia solution decreases, temperature decreases and pressure increases, and again the ammonia solution is fed to the expansion valve. The name itself indicates expansion, that is the expansion of the ammonia, that is the refrigerant takes place, and then fed to the pressure, high pressure ammonia, low temperature ammonia is fed to the evaporator, where the ammonia is evaporated, and then again which is fed to the absorber tank or absorber container, where the solution absorbs the ammonia, and the weak ammonia solution is fed to the circulating pump through the circulating pipe, again which is fed to the heating coil unit, where temperature increases, pressure reduces in the refrigerant, again which is fed to the condenser, where pressure increases, temperature decreases, and which is fed to the expansion valve, where the expansion of ammonia takes place, and again which is fed to the evaporator. So this cycle is continuous, process repeats. Due to this process, the heat extracted from the material kept in the freezing compartment. All of you observe here. This is the back side of the refrigerator, and the front side you have the freezing compartment, where you can keep food items, medicines, liquids and drinks. So you can keep the items for long times without decaying in the refrigerator. That is the advantages of refrigerator. Once again, I repeat, there will be two types of refrigerator. One is a vapor compression refrigerator. Other one is vapor absorption refrigerator. The difference between vapor compression and vapor absorption is the refrigerant used. So in vapor compression, you use Freon 12. In vapor absorption, you use ammonia as the refrigerant. The principle of operation of both the refrigerator are same. That is the components which are available in the refrigerator, that is starting from compressor or pump, next compressor or pump, next condenser, evaporator and expansion device. The same way in vapor absorption also you have circulating pump. Before that you have the absorber. So that's the difference between vapor absorption and vapor compression. In case of vapor compression, you have the compressor. Remember, you have the compressor. Compression, that is nothing but compressor, where you can compress the refrigerator. But here the absorption of the vapor, of the ammonia vapor takes place. That is the ammonia coming from the evaporator, which makes the ammonia vapor, which makes the ammonia vapor. So from the ammonia vapor, it is fed to the absorber. There, the absorption of the ammonia takes place and send the weak ammonia solution to the circulating pump, and you have the circulating pipe. Then it is fed to the fed to the heater, and here temperature increases. And in the meantime, it is fed to the condenser, where pressure increases, temperature decreases, and fed to the expansion valve, where the expansion of the ammonia takes place. Then it is fed to the evaporator, where the evaporation of the ammonia takes place, and which is converts the ammonia into ammonia vapor. So whichever vapor is present here, ammonia vapor, again which is fed to the absorber. So in the absorber, it absorbs the ammonia and makes the weak ammonia solution. This is the cycle. Cycle repeats. The heat is removed from the material or items kept in the compartment. This is the principle of operation of vapor absorption refrigerator. Vapor absorption refrigerator. Please, all of you, write down the question. Write down the question. Explain with neat sketch. Explain with the neat sketch. Vapor absorption. Vapor absorption refrigerator. Vapor absorption refrigerator. Continue the question. Put a question mark. Put a question mark. And after that, write down list applications. List applications and limitations. List applications and limitations. This is the last portion in your syllabus in module 3. This is the last portion in module 3. Say, all of you listen carefully. Among two types of refrigerator, one is 100% guarantee in the examination. For that reason, mark it very, very important. Mark it very, very important. Among two, vapor compression or vapor absorption refrigerator. Among two, one is 100% guarantee. Mark it very, very important. This is the last portion in module 3. Next class, I will start module 4. Next class, module 4. This is the explanation. See, all of you observe here the comparison between vapor compression and vapor absorption system. So please, all of you write down a question. Please, all of you write down the question. Differentiate between vapor compression. Differentiate between vapor compression and vapor absorption refrigeration systems. You have a question like this. Most of the question are in many of the question paper. You have a question in module 3. Usually in 6th question, that is in module 3. Comparison or differentiate between vapor compression and vapor absorption refrigeration system. Say you have 10 differences are there. In the examination, you have to write minimum 8 or 9. Sorry, if possible, write all the 10 differences between domestic refrigerator and the vapor absorption refrigerator. Next, come to the point. Already we discussed about the refrigerants used in refrigerator. First one, ammonia, carbon dioxide, sulfur dioxide, methyl chloride, freon 12 and freon 22. Freon 12 and freon 22. All of you observe here. Freon 12 is used in a fridge you have, refrigerator you have in your house, and the freon 22 which is used in air conditioners. And methyl chloride. See here they have mentioned small scale refrigeration, domestic refrigerator. They used in here also, but methyl chloride is used in cryogenic systems. And carbon dioxide used in marine refrigerator. See, because it should not corrode easily. For that reason, carbon dioxide. And already we discussed about in vapor absorption, ammonia used as the refrigerant in vapor absorption refrigerator. So that is the explanation of ammonia, carbon dioxide, sulfur dioxide, methyl chloride, and freon. And next, the properties of the good refrigerant. All of you write down, very, very important, the properties of the good refrigerant. See, all of you observe here, the refrigerant should have the thermodynamic properties, physical properties, self and safe working properties, and other properties. See, these are the properties of the good refrigerant. Please, all of you write down the question. Explain with block diagram the properties of the good refrigerant. So write down this flow chart. Write down this flow chart. Write down one by one thermodynamic property, physical property, safe working property, other properties. And these are the properties are very much essential for properties of the refrigerant. Next, that is the explanation of boiling point, freezing point, and other things. Next comes the point, the air conditioning. So this is very, very important. So this much is enough for you. I will continue in the next class. I will continue in the next class. I stop here. I will continue in the next class. Now I make now I make unmute to all, and I will continue in the next class. Now I end this meeting.